Hey everyone. In this video, I just want to introduce some basic techniques that you could use to prepare and explore data that could be used in a data mining process from within Excel. And so the data set that I've chosen to use, you can access from Kaggle. And I've already downloaded that and pulled it into an Excel spreadsheet. The URL, the link to the data set, I'll include in the description. So if you haven't accessed it or you don't have access to it yet, take a moment, pause the video, and then visit it and download it. And you will download it as a CSV, comma separated values file. I've already downloaded it and opened it within Excel and saved it as a workbook. So you can see here in the screen right now, I've got a worksheet that's open and I've created a description of the data or a data dictionary on this tab. Which is something that I like to do with data before I get into the exploration phase of it. But again, if you don't have this yet, just take a moment, pause, go download it, set it up so you've got it saved as a Excel workbook, and then we'll keep on keeping on from there. One of the things that I like to do, again, if you access that data, is you'll just have the data itself. And on the Kaggle page, the author provides a link to where the original source of the data came from, but also a description, and you can see descriptions for the various fields that are included in the data set as well. And so I like to just pull all that information down into the workbook so I have it all in one place. And so as you can see here, I've got the link to where the source came from or where the data set came from on Kaggle. I've provided a little description here about what this data is all about. We'll read that at you in a moment. And then a very, very basic kind of data dictionary here where I have the field names listed. I also include the type of data, so whether it's numeric or categorical, and then a description so that I get a little bit more information about what that field is actually capturing. And in my descriptions, I also include, in the cases of my categorical fields, the values that I would expect to see. One thing that you might also add, or sometimes I do, especially with larger sets, is in addition to the data type, I might also have like a subtype column here that I include for numeric types, whether they're discrete or continuous, and for my categorical types, whether they are nominal or ordinal. So again, the more information you can include here along with the actual data, if you're going to share this workbook with someone else, it makes it easier for them to understand what they're looking at and dealing with, and it'll save them from hunting you down and trying to ask you questions. So more is always better, I think, in the case of information. But if you know it's just going to be for you, and you're maybe just messing around with something to learn or have some fun with, then you might not be as serious about making all these entries in the data dictionary. But to give you a quick rundown here of what this data set is all about, and I'll just kind of read the description here. This data is a sample of credit card customer accounts as of 3 months in the past. Okay, and what we're looking at here is credit card customer churn. So the general gist is the bank has credit card customers, and some of them are leaving. Right, they're canceling their cards, and what we're hoping for is that by reviewing the data on past and current credit card customers, that we might be able to predict or classify which of our customers is most likely to churn or to cancel their card in the future, right? And so the hopes are, if you can identify customers that are likely to cancel their card soon, that you might be able to reach out to them maybe with like a promotional offer, or just say, hey, how are you doing, or whatever, something to keep them with you so they keep using your credit card, because that's how you make your money. So that's kind of the gist of what the data set is hoping to present and hoping to capture, and how we might go about using it. So the mining process here, when we finally get to it in a later video, would be a classification problem, right? So we're trying to classify or find a label for customers that have either, in this case, attrited, so they've churned, they've canceled their cards, or they've remained existing, right? So the target there is our attrition. And so that's kind of the gist of what the data is all about. And then having an idea of what it is we're about to do, we can then look at these fields that we have available for all of the number of customers that we have and start to ask some questions, to explore the data to say, hey, I wonder, if this is important, or maybe there's some insight by looking at the relationship between these two variables or something like that. And by exploring it, both numerically and visually, we might get a better understanding of which of these features, which of these fields are more useful in determining whether or not a client is going to cancel their card or not. And that's kind of what the purpose of this first video is going to be. So let's, without, again, reading all this at you, you can pause and take a moment to read that or again, have a look at it from the source. But I'm going to go to the actual data here, which is on this bank churners worksheet. And so now we can see we've got all the data laid out. We've got, in the first row, a header record. I'll zoom in here so we can see it a little bit better. So we've got a header record. And if we explore that, we can see all the way to A through U. We've got 21 fields. And, if we go to the bottom here, we can see we've got 10,127 data records. Okay, so it ends at row 10,128. But remember that first record is a header record. So we actually have 10,127 instance or example records that we can explore. And then just kind of going across, we can briefly look at what we've got for values. So we've got our attrition flag. This is the kind of the label that we're looking for in terms of classification. So we either want to see that a customer will remain existing, or in some cases, like we have here in example 23, whether they've attrited. And that just tells it that they've churned, they've canceled their card. We've got customer ages. We've got identified genders as being either, in this case, there are only two, male and female, a dependent count, education level. So this is, again, a categorical variable. We'll have to look at what the allowable values are if there. Marital status, income category. There are a number of different cards that the bank has. Months on the books, so how long they've been a customer. Total relationship count, which is how many products they have with the bank. And then there's some other things here about time, like months inactive, how many times they've contacted the support center in the last 12 months, what their credit limit is. So some of these things as we go through, we'll see we've got a kind of a mix of discrete numeric variables. We've got continuous numeric variables. We've got ordinal and nominal categories. So we kind of have a good mix of all the different data types that we might want to explore, utilization ratios and things like that. So before I do anything with any of this data, what I like to do to make sure that I don't inadvertently make some mistakes or alter this data is I like to make a copy. So I want to keep this here. This is kind of my base, my source. And then when I begin my exploration of the data, I might want to, for example, look at certain fields, and I might want to split them based on some category. And so I might add additional columns to the data. And I don't want that to exist in the data that we're supposed to analyze, but I do want to be able to make those adjustments so that I can perform some additional exploration steps. So the first thing I'm going to do is make a copy of this worksheet that I don't have to worry about messing around with. So I'm going to create a mover copy on the bank churners tab. I'm going to move to the end and create a copy. And so now I've got a new worksheet, and I'm going to call this data explored. So anything that I want to do with exploring this data or manipulating this data set for exploration, I'm going to do on this tab. Now, this is still just going to be kind of a source for the data. It's not where I want to summarize my findings. So I'm going to create another worksheet here, and I'm going to call this exploration summary. And it's on this worksheet that I want to include any of the information that I find relevant, or any visualizations, charts, and things like that I might create as I go about exploring the data. And so one of the first things that I like to do is just get an understanding for the shape of the data. So that is to say, kind of like I reviewed earlier, how many records do we have? How many fields are there? How many total cells are there? And then once I've got an idea of the shape, then we can start to ask some additional questions about what we see within the data. So let's just do that now. I'm going to make a data shape tab up here. And first thing I'm going to start with is the number of records. And then I'm also going to be interested in the number of fields. And yeah, then we'll kind of go from there. So this is where, Excel becomes quite useful. Functions are quite easy to use to get stuff out real quickly. So the number of records, again, we could just go and look at the data. We could scroll to the end, but let's say we had, 200,000 records. I might not want to just be scrolling around to find that information. So we can just use things like count functions to count them for us. So in this case, we could do something like this is equal to the count, and then we can go and find a range of values to count. Count counts numbers. So if we're going to use this function, we need to make sure we're dealing with numeric data. So I can go back to my data explored, and under the client num field, these appear to be all numeric numbers, so I should be able to count them. I wouldn't be able to, for example, count existing customer. I would use a count a function for that, but I'm just going to select this range, and there we go, right? So just confirming our intuitions here. So we kind of scroll to the bottom, identified there should be 10,127 records. It turns out there are. No surprise there. We can do the same kind of thing for our fields. So here, if I want to count the number of fields, I could count the record, the header record, the field names. So those are not numbers. So we could use count A and do the same thing. We can go back to our data explored, and across the top, I could just include the range for my headers. And we see, again, we've got 21 fields included. So again, so now I got some idea of what I'm dealing with. Okay, 21 fields, over 10,000 records. I'm pretty good. The total number of cells, this is not, super relevant, but is also something we could calculate, of course, which is just going to be a, kind of width times height. So this is just going to be total cells, which is equal to the number of fields we have multiplied by the number of records that we have. So now one thing to keep in mind is, again, I mentioned I might go back to my data explored sheet and add in additional columns. And of course, if I do that, that's going to mess with these calculations the way they are. So we'll make an adjustment here. Because I know I've based these functions off of what's in the initial data set, we can kind of freeze these values here. They're not going to change. So one thing I like to do after using functions to get these values is to just kind of copy and paste the values so that they're no longer tied to this idea of having functions that are used to calculate them. So for example, this first one, instead of now being a count, I can just Control C or Command C on your Mac. I can copy that, and then I can paste special values. And so now I've just got that as a number. If I go back to my data explored worksheet and make changes, this isn't going to change, right? So if I add a new record because I want to mess around with something, it's not going to change this value here. And we can do the same thing with these as well. So this one is, the total cells is calculated based on these two, and since they're not going to change, we could leave it, but it doesn't really matter. I'll just take both of them. Again, copy, and I'm going to paste special values. Okay, there we go. So again, this is just a nice way to make sure that I don't inadvertently make updates to my worksheet that changes these numbers later. Because if I use these cells in further calculations that I might have and they change, then that's going to change everything about my exploration. And I don't want that. I want everything to be static. So this is just some stuff that we can do. So before we kind of move forward, the next thing that I like to do is say, okay, this is what we kind of explored, but we haven't really addressed some of the concerns that I mentioned earlier. So, this is fine. We know there's the number of records, and this is the number of fields, and this is how many total cells we have. But before we can move forward, I really want to make sure that the data is, again, consistent so that we know what we're looking at is valid and we could use it. And a couple of those things that we look at, again, are blank or empty fields. So I want to know if anything's missing. If there are outliers, that takes a little bit more work. And for example, if things are like misspelled or there are malformed values, we need to inspect for that as well. But one of the simple things we can do now that we know what our total number of cells is to very quickly check whether or not we have any blank or missing. So this is our total number of cells. I'm just going to make an update here. We can also find if there are any missing. So what is the number of missing cells? And that's just going to be a function we can use for that too. So we can just use count blank. And count blank takes in a range, and will just tell us if anything in there is blank or empty. So I would expect that it would match this value. If we would get nothing. If we get a value, then we know that there's something kind of wrong. There are a couple of ways to go about doing this, but this is one. So we can just, within our data records, I need to think about how I'm doing this. Yeah, okay, there we go. So let's check the range. And it turns out we don't have anything missing. So that's great. And we can test that, for example, by coming in here. And let's say we remove the first client number. Oh, I started in, yeah. L2. Helps if you have the range correct. So this is why it's good to test your work. So let's go back and do that one more time. There we go. All right, so now it's correct A2 through U, so that makes more sense. And then we can come back in here and let's see what happens if we get an empty or blank. Hey, there we go. So now if anything were missing within that range, again, double checking your range, it's good to test. I see, okay, that there is one missing, but we know why. It's because I just got rid of it here. So fantastic. Nothing is missing. So that's important. If there were missing things right away, we would want to go and find those. There are a couple of ways to do it. We'll kind of explore that in just a moment. But since there's nothing missing, there's nothing critical there for us to kind of go and deal with right away. So let's just go back to the Explore data now that we have a little bit of a better understanding. And we can start to, take a look at this. One of the easiest ways to get some understanding of the data is to convert the range into a table. And then you get quick access to like the sort and filter functions within Excel. And this table is not that big, but even though it's not that large, like working with the data in a table in Excel can start to have like a negative impact on your machine's performance. So like I'm on a Mac, and if I work too long with my data in a table, especially with a large range like this, I start to get the like spinning rainbow disk of death. So I like to use the table early on, get some of my insights, out of the way, and then I convert the table back to a range so that it doesn't have a negative impact on the performance. But let's just first of all create this to a table or convert this. So on the ribbon, we've got, I'm in the range. It's fine. It'll find it. I'm going to choose Format as Table. Choose whatever lovely color patterns, etc. you like. I'll just go with medium. My table does in fact have headers, and fantastic. So now we've got this formatted as a table, and we can quickly kind of go through and see if, for example, in our categorical fields, if we have like weird values or things that are missing, if we wanted to find, strange outliers, in some of these cases, we can easily find that. So for example, if we want to know if there's any kind of misspellings or malformed data in the attrition flag, we can just click on the the drop down arrow here for the attrition flag field, and we see we got sort and filter options. But the important thing here is for me now in the filter area, we can see that we only have these two values. So that tells me that so we know there's nothing missing. So that's great. All the values are there. And of all the values, we only see these two explicit or discrete values. They're either attrited or existing. So that's good. If we had another value in here that was maybe attrited customer, but with one T, that might be something we can easily impute. So we'd say, oh, this is clearly just a typo or a spelling mistake. We could then filter based on clicking that one or unchecking the boxes for the other ones. And then we could find it. We could make the typo go away. We could correct it. And then it would match the rest of our data. So using the table can be a quick way, especially with ranges like this where we're only having 10,000 records or so, can be a quick way to find those malformed values or empty values where they can be imputed, and then just making the changes and entering them. So I might just go through a number of the fields. Again, gender, seeing here, okay, there are two. That's what I expect. Fantastic. Education level, we can see here we've got all discrete values, no duplicates. It doesn't look like any spelling errors, so that looks fine. And so we might just go through the list and kind of explore them that way. We might also want to have a look at briefly, what is kind of the ratio between existing customers and attrited. So we can, for example, Before we do that, let's include in here. So from the table option in the ribbon, we could also check the box for a total row. And then that'll include our total row at the very bottom. And now we can get things like, very quickly, counts, averages, sums, mins, and maxes. And we can quickly inspect the fields using the total row as well. So for example, here, I might want to count. So, if we're looking at gender, for example, again, we can see we have 10,127 records total, but let's filter that so that maybe we're only interested in females or identified females. So close this. And now we can see the number of identified females that we have is 5,358. So, okay, so that's just greater than half. And we want to flip that and look at males. Again, we can quickly see that there are 4,769 males. So again, we can use a combination of our total row and the filter and sort options to kind of get some more insight about the data. So here now we know it's pretty close to 50-50, but there are a few more identified females than identified males. So that's fantastic. Okay, so again, using that total row, again, can be useful. And you can find averages, mins, and maxes. Again, finding if things are kind of funky or not. So in the customer age, we might want to know, for example, what's our minimum, like what's our youngest customer? So the youngest is 26, and we can quickly see, well, what's our oldest? 73. Now, this doesn't tell us anything about the distribution of those ages, right? So we don't know if the majority are young, the majority are old, or in the middle. For that, we can use histograms and we can use some visualizations to help. But for kind of quick information about some of the details, I recommend converting to a table and then taking advantage of this total row and the sort and filter options that are on these tables. I think for now, I'm just going to leave that there. So once I'm done with this, I'm going to go back to the table on my ribbon. I'm going to uncheck the total row. I don't want that anymore. And I'll go back to the very top. And I'm going to use this option to convert to range. Because again, I don't want the table. It's compute intensive. Might slow my computer down, and I don't really want that. So I'm going to convert this back to a range. If you want to spend more time exploring in the table setting, like I said, please feel free to do so. My intent in this video is to kind of, not in a race, but just kind of without spending too much time, show you the techniques that you can use to explore the data. So let's convert this back to a range. Say, yeah, are you going to want to do that? Of course. And then it's still going to leave all the formatting. So I like to just kind of highlight everything, and we'll revert everything back to a normal cell. There we go. Okay, so that's how we could use tables to inspect our data a little bit. So one thing that now we've done that, let's start to, and we've talked a little bit about cleaning our data. It doesn't appear that it needs to be cleaned. The data is fairly consistent. This being kind of like a training or an introductory data set, we don't expect too many crazy things within the data. So good for us, but we've done a little bit of that exploration here, so nothing was missing. So the next thing I want to do, keeping in mind what it is that we're dealing with, is we're trying to be looking at the data through the lens of identifying attrited customers, so customers that are leaving. So let's find out what proportion of our data set are in fact attrited customers. So we can set that up here. I can say, what's my target? The target is attrited, and what I'm interested in is the number of attrited people. So that's going to be equal to, again here, essentially a count. So before we kind of put the formula in there, let's think about how we might go about doing this. So we have an attrition flag, which has one of two values, like we've seen, existing customer or attrited customer. And what I want to do is basically count, here if I have a value that equals that. So if looking through this entire range, if we see an attrited customer value, we want to count that. So that's basically it. So here we can say it's equal. So we want to count. Specifically, we want to count if, right? And so we pick our range. We say, okay, we want to look in this attrited set. So B2 through to the end. So that's my range to look in. The criteria is attrited space customer. And so if that matches, and you make sure you spell customer right, that helps. Then we can see here we've got, again, 1,627. Now, this is my way of doing it with the function. We could have done this with the data set converted to a table. So we could have used that total row and just filtered, attrited, and got the number from there. And in fact, if you want to confirm that this is correct or not, you could go back and do that again. So I'm just showing you again another way that you could go about getting these values. It's not necessarily the best way. You decide which is more comfortable for you. At the end of the day, people are just going to be interested in the numbers. They're not really going to care about how you got to them. So I always tell people use what's feel comfortable using and what you're going to be most effective with. So that's part of the story. This is our number of attrited, and this is our total number of records. So what we might want to do is figure out like what is that as a percent. So the percent attrited, is just going to be equal to, and again here I'm going to use now that I've got this value, I'm going to Command C, I'm going to copy it, and I'm going to paste special values. I just want the number, and the percent is going to be equal to this divided by our total number of records. And we can format that as a percent. So we've got approximately 16% of our customers in the data set are customers that have canceled their cards. So that doesn't necessarily tell us whether or not our ability to classify will be good or bad, but it is something that we might want to keep in mind when we get to a later stage of actually performing some data mining. So when it comes to thinking about our training and validation and test sets or series, like do we want to make sure, for example, if we have a training set and let's say a holdout set that roughly 16% of the records in our holdout set are attrited versus existing. So some things like that are things that we might want to keep in mind for later. So this is why that might be important. But for now, that's okay. I would expect again 16% if we were to run this in the future to kind of come out with the same attrited value. So that's kind of how that goes. Now that we have this in front of us, we can start to ask some questions about, what are we looking at in terms of the individual fields themselves? And so one way to quickly do this, I'm going to zoom out a little bit here so I have some more kind of space. So it might be difficult to read on your screens, but I'll tell you what fields I'm on, if nothing else. One of the quick ways to go about visualizing things here is to just use some of the built-in charts that exist in Excel. And so it's not going to work for everything. For example, if I wanted to know what the split is here between male and female, again, I could use that table and get those values, but I can't, with values of M and F, make a chart to show that to me. The charts need to work with numbers. So that's not going to work. But where we do have things that have numbers, then we can start to ask some questions. And so we might be interested in, for example, like distributions. So as an example, let's just pick on something here. Dependent count. We might want to know what the distribution of dependents is amongst our customers. So we can go ahead and we can select this column and we can go to our Insert tab. And then in the chart section, we've got a couple of options here. We're interested in the statistics. So under here, we've got a histogram. So we can select that, and then we can see what that produces for us briefly. Now, it's going to, by default, kind of automatically choose the number of bins that we use here to capture or hold these, but we can adjust that a little bit here. So if we click on a data series, just one, and we right-click, we can choose to format it. And then with this histogram option for charts, we get some options here about what we want to do with the bins. So you can see by default here, it's automatically built. There's an underflow at -2 and overflow at 6 if we want to choose those. But I'm going to go with number of bins. And you see here it's got 24. I'm going to go with 6 bins and see what that does. Okay. And so now we can see what those ranges are for those bins. So 0 and then 0.8. So there's nothing going to be 0.8. You can't have like 0.8 dependents. So that'll be like a 1. So that's what we're looking at here. 2, 3, 4, and here 5. So we can kind of get a feeling for how the dependents are distributed. So again, kind of a normal distribution, the average values being somewhere in here, about 2.5-ish. So if we were to compute the average on this field, I'd expect a value somewhere there. But this is just a nice kind of visualization where we can see how things are on the ends. If the distribution is skewed one way or the other, or it's a normal distribution, kind of like this one, it's a nice, easy way to kind of quickly visualize it. So once I'm done with that, I kind of delete it. I'm just quickly looking at things to get my idea about what the data looks like. So let's say also for age, we might want to get what's the distribution of ages. So again, we can kind of highlight that field, and then we can choose to insert a histogram. And so same thing, we can expand that a little bit. We can right click on our data series, and we can change the number of bins. Maybe you could go by bin width. So, maybe the bin width is increments of, 5, right? And so instead of choosing the number of bins, we can say, well, they equal width. So here, 26, we saw that earlier when we were exploring the table, that our youngest customer was 26. So that's where we see here, 26 to 31. We can see, and if, again, this goes up to, up near 2,500. If it's difficult to kind of get a feel for the numbers, and that's what you're interested in, you can, again, kind of right-click the data series and add data labels, and now I get the numbers. So we have 356 in the first bin, 784. Again, here we see a fairly normal distribution. We've got a couple of older customers here, but the majority seem to lie right in here around the 45. So around 45 years of age is where I would expect to see our average age of customer. And so, okay, great. Now we have an idea about how to answer that and also how the distribution falls. So histograms are really good for looking at single variables. They're one way to do it. Another thing we could do, instead of looking at the histogram, still having the customer highlighted here, is to use our box and whisker chart. So that's going to be down below. You see that's still in statistics. Scatter we'll get to in a moment. So still in statistics, we can see our box and whisker. It's just kind of another view of it. I don't want to say essentially the same thing, but kind of the same idea. Okay, so we're getting an idea of how our customer age is distributed. And so we can see here, this is in terms of quartiles. So within the allowable distribution, we've got our first, second, third, and fourth quartiles. And then here we've got kind of our tail entry. So these are kind of our in the histogram, those older customers that we saw. We can see there's only really two of them. There's a 70-year-old and a 73-year-old. But otherwise, we've got everyone kind of between 68 and 26. And then in here, this is our second and third quartile. So 50%, right, of our customer age group, again, are in this range with the mean average here somewhere around 46-ish. We can view all the values too. So just like we did with the histogram, if you right click on the data series, you could choose to format it. So you can, put in show inner points and do some other stuff. The inner points will just show you kind of like all the ages, which is too many. So make sure that's not checked. I don't really care about much of those other things, but what I do want to do here is add data labels. And so they're kind of difficult to see. But if I zoom in, we can kind of see them a bit better. And so here again, you can see those actual numbers. So the mean average is 46 and some change. Again, median 46. We've got our bound levels for the quartiles, and then here are outliers. So yeah, so again, just another way to kind of view the data and get a better understanding of what the distribution or what the ranges are within each of these fields. So a couple of different ways that you can use charts to visualize. Before we get into correlations, let's just stick with that for a moment and say, okay, we've identified a couple of categories, and we might now start to develop some insight to say, well, I wonder if there is, any relationship to, the attrited customers and, let's say, maybe age, maybe not, but we have income category or even education level, right? So let's just say we want to look at that and say, oh, hey, maybe, customers of a particular education level have a higher attrition rate than others. We don't know. So that's something that we might want to explore, but it's not at once kind of obvious how we might go about exploring it, right? Because we can't create like a chart, and these aren't numbers that we could compare against. So there's a couple of things we could do. One of them includes creating a transform for this field where we would create category scores, which is something that I'll talk about when we get into preparation later. But for now, because of Excel and the different functions that are available, we don't necessarily have to go that route. So let's just set this up really quick. Again, I have an idea of what my allowable values are. So for education level, we've got I'm missing one in here, but we've got high school, college, graduate, postgraduate, doctorate, and uneducated. But if we look at the data explored, we see here we also have this unknown. So we do have an unknown value that we want to take into account. So let's go back to our exploration summary tab and make some entries for this. So again, what we're going to do here is just try to look at our data based on education level and see if there's anything there. It might turn out there's not. And a lot of the time that you're going to spend in any kind of data analytics or data analysis process is really going to be in exploring and preparing your data. So a lot of times you might find it's a dead end, but you don't know until you go down that road. So I'm going to be looking at education level. And so we can do a couple of things. So let's identify first the level. We know we have unknown, we have uneducated, we have high school, we have college, we have graduate, I believe, and then we have postgraduate, and we have, doctorate. All right, so those are our different levels. So we've got 7 of those. Fantastic. And so now what I need to do is get a count of customers that each have that level of education. So we can have a count field. And this is going to, again, require us to perform some analysis on the worksheet where we can say, hey, let's look at the customers. And if their education level matches this, then I want to count it. So that's going to be, again, some other kind of function. So this is going to be equal. So there are a couple of ways we could do this. So we want to count, and it's kind of like if, let's try this. So let's just try a count if. We can look at our range, right? So that's going to be education level. So we can highlight that. And here I'm looking for unknown. All right. Okay, so according to this, we have 1,519 unknown education level customers. Okay, and if you feel confident about that, then we can just basically copy and paste this into the remaining cells, just changing for this value here. Again, if you wanted to quickly double check that the function's correct or that you're getting results that make sense, we could have that data converted to a table, and then you could use the total row to kind of double check your work. One thing about working with Excel is, and you've seen it already in this video with myself, is you have to be careful about typos. So question things. I often try to get not a second opinion, but look at things 2 different ways just to make sure that they align before I move forward. And that gives me some more confidence in the work that I've done. So rather than kind of click and drag this down, because that's going to change field values, I'm just going to copy this and then I'm going to paste it. Oops. Oh, I missed it somewhere. This is the best part about Excel is when you, there we go. And so now what I can do is in each of these cases, just change it with the value. So uneducated. And now we can look at high school, college, graduate, postgraduate, and doctorate. Okay, so now we get kind of an idea of what the distribution is of our education level. So kind of in the same way we looked at the distribution of ages, we can now see we have like a frequency or distribution of our education level. Speaking of frequency, that would be another way that we could have gone about doing this. We could have created bins, so bin values, let's say 0 through 6, and we could have used a frequency function to count the frequency of these known levels. So that's another way that we could have gone about doing that, but there's a couple of ways to do it. This is one that we've already used the countif function before, so that works. Let's, okay, great. So again, what I'm going to do here is instead of keeping these things, let's just modify them so that yeah, I was going to say maybe we'll do the frequency thing, but we'll leave it. So let's modify these again. So I'm going to Control C, and I'm going to paste special values. That's all I care about there. Awesome. Okay, so now that we have these values, we can start to look at them a little bit. One thing I might want to do is just highlight these things, and let's do an insert. Let's do not a histogram, but a bar chart. And so now we can kind of get a feeling for what that looks like in terms of our customers. And if you wanted to format this so it looks a bit more like a histogram or something, you could. So we can kind of see, again, the majority of our customers are graduate level education, high school the next, and we kind of get a feeling for what that looks like. And this is a categorical field is, in my opinion, ordinal, right? So you would need high school before college, before graduate school, before postgrad and doctorate. So when it comes to kind of looking at these things, there is some kind of a natural order to the category itself. So that doesn't really matter too much right now, but that's kind of the idea. So yeah, we could do the same thing where we could right click on the series itself. We could format it. So we could, for example, let's reduce the gap width. Maybe we don't, or we go with like a 2% gap width or something like that. And I also like more muted colors. So let's change the fill color, something like that. Okay, so there's nothing really stand out. You might want to highlight that, hey, this graduate level is quite high. Maybe there's something important about that. So maybe we have that one as kind of like the standout. And we could also add some data labels. And so I'm not going to spend, again, a whole bunch of time formatting these charts, but sometimes it makes a lot of sense to, I like to remove grid lines, things that are not necessary. I probably don't even need this. Let's get rid of that too. Yeah. Okay, so education level count, we can see in every education level what the count is, and hey, this is rather high. So fantastic. Okay, so now we know what the distribution is there. Maybe we want to do some other things. For example, we're interested in attrited customers, so let's have a look at that. So let's get a percent of the total, first of all. So of the total number of records, how many are unknown? So this is just going to be equal to this value divided by the number of our total records. Right, so here we can see we've got just about 15%. And in this calculation, I want B2 to be absolute reference, so we can use F4 to do that. And now we should be able to just kind of drag this down and get the rest of those and format them as a percent. So about 15% unknown, 14.6% uneducated, 19, et cetera, et cetera. So graduates, again, no surprise. We can see they make up a large chunk here. Again, because we have around 10,000 records, 3,000 is roughly 30%. So that's kind of what we see here. Crazy, no big deal. Now, that doesn't tell us much more than we can already visualize. But what I am interested in now is the percent of these at these different education levels that have attrited. So let's get that next. So the number of, for example, unknown education level customers that have attrited. And so how do we get that value? Well, we need to know this is how many we have. Well, how many of these also attrited? So for this, we can use another function to do our counting. So this is going to be equal to count if, but I want to count if multiples. So I want to count them if their education level is unknown. And I also want to count them if their attrition flag is attrited customer. So those two things need to be true. So we can use the COUNTIFS function to do that, where we specify a series of criteria, ranges, and criterias. So the first criteria range is going to be kind of like what we already have. So let's first look in the education level range. I'm looking for unknown as the criteria. The second range is going to be my attrition flag range, and I'm looking here for attrited customer. And so those two things need to be true. And so I can see from that I have 1,519 unknown level education customers and 256 of those attributed. So we can do the same kind of thing here. The F2 is going to be the same, so I want an absolute reference there, so I can use F4 for that and F4 for this. And then also with beat, I can say F4 and F4. And so now I can take this and I can copy it down. It should be the same number in all the cells, but we can just go one at a time and change them. So in the first case, I was looking for unknown. Now I'm looking for uneducated. So I have 237. Now I'm looking for high school, 306. Now we look for college. We look for graduate. We look for postgraduate. And then finally we look at doctorate. So again, because they're relative, this doesn't tell us anything, beyond in terms of total numbers, how many have attributed. So 95 of our attributed customers have doctorate level degrees. So great. The majority of them, no surprise, because graduate level education customers make up, a third about of our customers, they make up the majority of those that have attrited. So there's no real surprises there, but maybe we can go one step deeper and look at, well, what is the attrition rate within the group itself? So let's look at percent that have attrited. Oops. And so that's going to be equal to this value divided by this value. And again, because those are relative calculations, we can kind of drag that down and we can do the conversion to a percent. And so here we see, this is kind of interesting. I'll just bold that approximately, 15, 16%-ish, that's where we see most of these. But at the doctorate level, we see that's kind of a bit higher. So is that going to be a standout feature? I don't know. There are only 95 attrited doctorate level customers, so we might not care a whole bunch, but it is interesting, if nothing else, that this is, kind of a bit higher, than the other groups within this particular range. So we could, for example, we could chart that too. So let's say we have something like the following. Can I do this? I'm just trying to think about how I might go about doing it. Yeah, let's do that. And we can insert another bar chart. Oh, that didn't take the data the way that I had hoped it would. So let's build this one kind of up from scratch. So let's do an insert. We can say yeah, we'll build it from, so let's go bar chart. Fantastic, there it is. And then we can select our data. So the chart range, sometimes it's easier to just grab the whole thing. So I'm just going to grab the whole thing for now. And then it'll highlight all the different series that are inside. So what I care about is not count, is not percent total, is not even attrited, it's just attrited. So, and then the summary D3 through 9, that's correct. Yeah, let's go. Fantastic. All right, and so now we can kind of see what that looks like. Percent attrited within groups, within education level. And we want to be a bit more clear about that. So percent attrited within education level. And we can do the same thing. We can format this data series. So again, without spending a whole bunch of time, just do a little bit of cleanup. Let's go with a muted color. Yeah, there we go. And this one might be the one that we want to kind of show as a standout. And then we can make some updates. Oops. Let's go with a 2% here again. Okay, and then so same thing. We could add data labels. Right, we can clean this up, make it a bit easier to read. We can get rid of this on the left, and we can get rid of, our grid lines, and it's a bit clearer and easier to read. So again, not to say that that's anything that's statistically relevant, but that might be of interest for us to look at. I mean, looking at them, they're all pretty close. Who knows? It's a small batch, so there may or may not be really much there to look at. And so that's one way we can go about looking, again, kind of within categories. So we might be able to break them down, pull out some values using some functions, and then kind of see where we land. Another thing that we might want to look at is the breakdown in terms of maybe with gender. That's a possibility too. And so there's a couple of ways to go about doing that. So let's say, for example, we're interested in, let's do here, I'll say gender exploration. And so if we wanted to look at, let's just say the split between genders, we would need to set that up first of all. So let's look at, we have female, male, F and M, and then we could look at the totals for each, and then we could look at the percent of the totals. We could do that too, but I'm more interested in the percent tritted. So maybe there's a difference between the number or percent of females that cancel versus the males that cancel. It may or may not be the case, but it's something that I might want to be interested in. So let's look at, we need this in order to get the percentage. So let's do the same thing. So we can go for total. Again, this is going to be equal a count if, and we're going to go look at the gender column. So we can look here. If that equals F, we want to count it. So there's that number that we saw before when we were looking at the table. And I'm going to do the same thing. I'm going to copy this and paste, and we'll change that to an M. Awesome, fantastic. So same thing here. I'm going to, now that I've got those values, I'm going to copy, I'm going to paste special values so I have the static numbers. Number that I've attributed. So this is again looking at, now customers that match gender F, but that I've also attributed. So very similar to what we've done before. Pretty much a copy paste of the same thing. So I'm going to go a bit quick through this part. So again, we can use a count if series. We want a couple of these things. So here, if this is equal to F, and then the second range is going to be our attributed customers. Customer, fantastic. So we have 930 of those. Same thing, I'm going to copy this. I'm going to paste it and then change F to, M. All right, and so now we can do our percentages. One more time, now that I have those values, I'm going to Command C, I'm going to copy, paste special values. I don't want to mess around with that. Okay, this is going to be equal to this divided by that. And same thing here. And we can format those as percents. So interesting. So females, I mean, they do make up a larger chunk of our total customer base, but within females, right? So this is not overall. Within that, over 17% cancel, whereas for males, under 15% cancel. So again, is it a material difference? I don't know, but they're not close. They're not, within a percent of each other. So there might be something to that. There might not. At somewhere down the line, the decision as to whether or not the customer is identified as male or female may have something to do with whether or not they're going to cancel their cards. So again, this is just looking at values. And we could do the same thing. I'll leave it as an exercise for you where we could create a chart to visualize this if you wanted. Now, one thing that we might want to do that I will spend just a moment on is seeing the split visually for some of the other things. So for example, in terms of distribution of age for male and female, that's not something we looked at. So for example, for age, we were able to look quickly here and highlight the field and insert a histogram, and then we could see what the distribution of ages was. But we didn't get a chance to quickly see what the distribution of age was by female or by male. So that might be something that I'm interested in. And so one of the easiest ways to do that is basically to take the field that you want to split by and then use that to split the field that you're interested in by that category. So what I mean is, rather than just having customer age as a single field, I'm going to take this, and based on the category I want to split by, which is gender, I'm going to create 2 additional fields. So this is what I meant earlier when every time I have a calculation for one of these things, I like to copy and paste the values because I might come in here and want to make updates and add things to my data set. So here's an example. So I'm going to insert a new field here, and I'm going to insert a second one here. So I'm just picking on age and gender, but we could do this with any number of things. In fact, we may do it again when it comes to looking at correlations. So what I'm interested in here is, for example, F, customer age, and M, customer age. And so how I'm going to get those values is by using the gender field to split the customer age field. So here I want to say for female or F customer age, that's going to equal, and now I have to do a check. I'm going to say, how do we want to do this? Oh, it's just if. Geez. So if we look at the gender, and that's equal to F, then I want this C2. Okay. Now, if that's false, I don't want to put a 0 in there because I don't want to chart a 0 in the chart. So we can use the NA function to get an NA value. So that won't be charted. And so what I can do once that's in there, so this again reads as if this field here is equal to F, then I want the age. Otherwise, I want NA. And so that's what we see now. And so if we go down, I'll just double click to use the fill handle to fill that. We can see here's an F and I get the value of 49. Here's my next one, I get 40. So now I'm only scoring values or ages here for female customers. And then we basically do the same thing for our male customers. So I'm going to copy this. I'm going to paste it in the M customer age and change F to M. You could base it on this field now, but I'll use the same and then again kind of paste that down. Now these, if I sort them, they're going to sort together. So I'm not going to worry about copying and pasting values, but that's kind of how this looks. Yeah, I don't care about that. Oops. So there we go. So now I have fields for F customer age and M customer age. And now we can kind of visualize them together. So if let's say for example, let's go across these, or let's do that for now. We can try this. So let's insert, this could be kind of tricky. I'm going to try something here quickly and see what this looks like. Yeah, it's not going to separate them. So we get both. What we might want to do is actually create bins, on our own. So that's fine. Here's one way we can go about visualizing these things using Box and Whisker. The histogram I'll leave. So we can highlight these. Let's insert, again, statistic, Box and Whisker. I'm hoping to get both. And now we can see both of those series added here. And so I don't have labels, but that's fine. We can see, let's add some chart elements. So let's add a legend to the bottom. Okay, so we can see blue is F customer age, orange is M. I don't care about the 1, that's kind of meaningless. And we can see that the distributions here, or at least the ranges as far as the box plots are concerned, are pretty much the same. We've got a couple of older male clients here, but 67 on the top, 90th, 68, 26, so the minimum age customer is the same. And even our average values, 46, 46, it's pretty much the same. So there's not really any difference between the average age between males and females, but what we don't see is the distribution. So we could have some like really old, more old and, whatever, but that still tells us that the majority of, at least here, between 41 and 52 are lying in this range. So you could still produce a distribution, but like I said, without taking a whole bunch of additional time, I'll leave that as an exercise. So I'm going to just cut this chart from here, and I'm going to go back to my exploration summary, and I'm going to include it here. Ooh, it's rather big. Let's shrink that up a little bit. All right, and then we can go in and we could add data labels, and add data labels make it messy. We'll leave that for now. So again, clean it up, add, you can remove these. There's certain things I don't like, remove the grid lines and things like that. But anyway, and add a chart title. So we could say this is customer, age by gender, something like that. Fantastic. So again, am I going to inspect that a bit more? Not really. Looks the same between both, so I don't think there's much there to look at. Okay, at this point, if we wanted to kind of break it down a bit further, because we know within, for example, genders, we know that there are education levels, there are also income levels. We could continue in this way, but this can become quite tedious. So one thing we might want to do at this time is create a pivot table. And pivot tables and pivot charts are other good ways to kind of quickly get visualizations in terms of, the pivot charts, but just pulling out data like this in terms of the pivot tables. So you can build all this stuff up manually, but it takes time. Let's go back to our data explored. I'm going to leave all this stuff the way that it is. And what I'm going to do is I'm going to insert a pivot table. And it's going to ask, do we want to, what's the range? And this is the correct range. So A1 through, in this case, W, because I've added those 2 additional fields, so that's fine. And I want to create this on a new worksheet. So let's say, okay, fantastic. So now I get a new worksheet. I'm going to call this, I'm just going to call it pivot table. And so now we can kind of build a pivot table up that could be useful for, again, finding some of these things. So let's add some stuff to this. We've got our fields. I'm going to zoom in a little bit, and we can kind of see how this goes. Again, I'm not going to do an exhaustive exploration, but I'll show you a couple of things that we can do with this. So what are we interested in here? Well, we're interested in, let's say, looking at, let's start with gender. So I want my data in terms of rows of gender, and then I also want to sort by, where do I find it here? There's all kinds of things, but let's education level. We'll put that in there first. So now we can see within each of these genders, the different education levels. And now we need some kind of a count. I'm just going to look at the, let's use attrition flag as the count. So here we can see those numbers. So attrition flag is going to count everything. So total number of F customers, total number of M customers, and then within. And so that's just counting the flag, but we need a filter. So we could also use the attrition flag as a filter. And so now we can say, okay, if we just look at attrited customers, what does that look like? So here's our 930 that we saw from our exploration summary, right? So again, we can kind of see that our numbers are correct. And there we go. Here we can see the 697 here for our male customers. So that's good. That gives us some confirmation that we did things right previously. But we can kind of see what this looks like. So, what the numbers are. Is there anything that kind of stands out? And it's like, no, we know that there are more graduate level education customers throughout the data set. So I would expect graduate level to be higher than the others. There's nothing really too crazy about that. Maybe I don't care so much. So rather than looking at education level, there's not much there. Let's just throw the attrition flag in here. So let's do it that way so we can look at attrited. Oh, hang on. This is going to give us a problem. So let's get rid of that, uncheck it, and then there we go. Let's get both. So now we can see both are attrited and existing, and still by gender. That may or may not prove important. But let's look at some other things. So if we look at what we have available, here's where we can start just dropping in a bunch of things. So maybe credit limits. Maybe there's a difference between credit limits. So I don't want the sum of the credit limits. I want maybe an average. So we can right click on the field header, and then we could choose summarize values by, let's say, average. And so these are let's call them currency values. So let's do that. And so we can see the average credit limit is lower for females than males. Okay, that's maybe interesting. We don't know. But there's not really much difference within. So So females are lower than males, but within female, there isn't much difference between credit limits of attrited and existing. Same thing with males. So there might not be really anything there to look at. Okay, let's go and look at some other stuff. So maybe we want to look at, maybe we want to look at revolving average balance, or how many transactions they make, or we want to look at the age. So we were talking about ages earlier. Let's do that here too. So where is customer age? So we can do that. So, I grabbed the wrong one. I want customer age, not F or M. There we go. And so same thing here. So I've got the sum. Again, I don't want the sum. I'm going to choose summarize values by, here we'll do an average. So like we saw before, no real difference in age between attrited and existing. They're also about the same. So there's no real difference. No big deal there. What about some of these other ones? Let's look at average utilization ratios. So again, I don't want the sums. Let's go with average. Oh, this might not, because it is a ratio itself, that might not work. Yeah, we'll just go by count. So that's not really helpful. Thinking about the data shape is also useful. Total transaction counts, or why don't we do something like that? So that's in there. It's not, maybe that's why it was formatted. Let's go to general. And again here, I want average, for example. Okay, so this is interesting. So now we have something that's a little bit interesting. So between F and M customers, not a huge difference. But within attrited and existing, right, attrited customers only had a total of average 44 transactions. Close to that is, again, for M customers, 46. But the existing had much more. So existing customers, it appears as though they use their cards much more than our attrited customers, which, if we think about it, might make sense. Someone who cancels their card is probably someone who doesn't use it very often or uses it for small purchases. Someone who's an existing customer probably uses it all the time, and maybe they're making much larger purchases. So those are things that, now that I'm seeing this, might say, oh, okay, maybe there's some other things that I should look to. So it might not even really be, as I can see here, there's something interesting here about males and females, but that says more about differences here in credit limit. It doesn't say anything about attrition. So let's get rid of that for the moment. We'll get rid of gender. So now we're just looking at attrited versus existing. So average credit limit, no difference. Age, no difference. But here, now we can see there's a dramatic difference between the average total transaction count. And I might also want to look at the total transactions amounts. So let's pull that in here. And also, let's do an average of that too. So here we can see the average total transactions amount, again, much lower for attrited than for existing. So there's something there. There's some kind of correlation between, for example, these two variables, the total transactions and the transactions amount. So that's something we could look at. Now this is useful. We might want to throw, just to show this, gender up in here again as a filter. So now if we wanted to, we could still look at M versus F, but we have it kind of as a filter versus what we see in rows. So for males, still that difference, nothing else really changes. And then for females, same kind of idea. So anyway, and then we can clear the filter and get rid of it. So that's how we can use pivot tables to help. But we might also want to use a pivot chart to help us as well. So we can use pivot charts to visualize this stuff. So let's just show that as an option. One more thing here, data explored. So again, insert. In this case, we go over to pivot chart. Same thing, same range. So A through W, and I want it on a new worksheet. Fantastic. I'm going to rename this pivot chart. And so we do basically build it in the same way. We start dragging things on and see what it looks like. So one thing we didn't look in the table was income amounts, or like earned income ranges. So let's look at that category. So let's drop on, let's say, gender and income category. So now we can see what that looks like. So we can split. Let's zoom in here. We can move this over. Okay, so we have females and males. And one thing that becomes immediately apparent, let's also drop the attrition flag on because that's what we care about. So counts, is when we look at, what are we looking at here? Income categories. Males kind of span all the income categories, except for, if we look closely, they've got less than 40, basically everything. But the female customers are only less than 40 and 40 to 60. So, and then there, of course, is the unknown. So we don't know. There's 1,000 in here that we don't know about. So far fewer females prefer not to say, or just we don't have a record of what their income category is than males, right? There's like a 20% here versus like nothing. And beyond that, though, we don't see a labeling of females in these ranges. So before, in our pivot table, we still have this. We saw, for example, the average credit limit for females was, around 4,700 or 5,000 or whatever. And then for males, it was much higher. It was 12,000. And so again, not that this is relevant necessarily to attrition, but is interesting to note that, hey, like, did we know that most of our female customers, right, they're earning less. So who knows? If we do find that females are canceling their cards more often, maybe that has something to do with this. I don't know, but it could be something to look into. And so here in the chart now, we kind of get a nice visualization of that too. You can kind of mess around with these things. So one other thing we might want to look at that we haven't so far is another category. Let's say their card category. So we might have a filter for card category, and we can see that there are a couple of different products here. So we have blue, gold, platinum, and silver. We could even add that to the chart, but it'll get kind of messy. So we could look within card categories. It turns out that blue cards are the most prevalent. And so we can see what that looks like. And then golds, right? We can see how many, not a whole bunch in there. Platinum, not a whole bunch of platinums. Silvers, a few more silvers. So you can see the majority of customers are blue card holders, but that's the same across both male and females in terms of averages. So nothing too crazy to see there. But again, without having to take the time that we spent kind of building up these little tables and then creating charts to visualize them, which there's some value to. We have full control over these charts, so it's a bit easier to manipulate them. But sometimes it's easy to just create a pivot table or a pivot chart, and then you can just quickly throw these fields into the different areas and then visualize things. And you can always change, of course, the visualizations, right? So you could change design, so you could change the chart types, stuff like that too. So this is a really nice, quick way in Excel to quickly explore some of these relationships. Okay. We're going on quite a little bit here. The last thing I want to do before I break on this particular session is just look at correlations. So there's one final thing that we want to look at when it comes to exploring relationships between variables. And oftentimes we'll use correlations to do that. So whereas distributions and box plots are typically used for single variables, we might want to see if there's any correlation between, let's say, two variables. And actually, if we looked at this, we kind of saw this a little bit here. We see, for example, that the average count. So there's, what's the relationship, if any? Is there any correlation between the total count and the total amount that we spent? So that might be a question that we have. There are other things that we would expect to see correlations between. So, for example, when we look at let's go here. If we look at our data and we see, things like average utilization ratio. So I would expect that, customers with lower credit limits will probably have higher utilization ratios. They probably use more of that limit than someone who has $1,000 limit. It's probably using more of that limit than someone who has a $35,000 limit. That's not a guarantee, but I might want to investigate that. Or, for example, the average open to buy, so how much room is on the card to make a purchase, that probably scales with the credit limit as well, right? So the higher your credit limit, probably you have more room to buy stuff. So I would expect there to be a positive correlation. So these are some of the questions we might have, and we might want to go about investigating them. So for example, let's say we want to do, I'm going to make a little space for this. So in our exploration summary, I might want to look at correlations of things. And so let's go back to the data. So I might want to look at that. I might want to look at, let's pick on these two right now. So let's say credit limit and total revolving balance. So I'm going to select these two columns, and I'm going to choose to insert. And now we can go to the scatter, and we can see what that looks like. So I'm going to just run through a couple of them. They're not going to be great, but it gives you some idea what to look at. So here you can see if there's any correlation. And what we would expect to see is that there's like a trend in some kind of direction. But as you can see here, there's not really like a trend. We have credit limits and revolving balances. So credit limits go from 0 all the way up to 35,000. It looks like that's the max. So nobody has a higher credit limit than around 34,000. I think what we're looking at here are the limits of the data for the training set, right? So there are probably some limits on how this data set was built. But that being said, you can see the hard limit is kind of on the max credit limit. And also here we have a limit on what we see in the data as far as revolving balance. And then kind of everything in between. So there's not really any correlation there. I would expect to see correlation values very low. What are some other things that we could look at? There's nothing really over there. So let's say, what we were looking at. So let's say, for example, we want to look at total transactions amounts and total transaction counts. So these are the two that we had seen here, right? Counts and amounts. And we want to ask a question about, if maybe there's some correlation there. So we can do the same thing. So we'll highlight those. We'll insert our scatter plot, and lo and behold, we do see not only is there some clustering, so that's interesting. There's clusters of customers here, but there also appears to be a correlation, right? So there appears to be a positive correlation upwards between what we can see here as the transaction amount and the number of transaction counts. So we could swap these things. So let's here to show you what I mean. So what we're trying to think about is like, what is the dependent variable and what is the independent variable? And so again, they're both kind of used, but we might say that the independent variable is the count, so how many, and the dependent variable is the amount. But for our purposes, it doesn't really matter. I just want to see if there's any correlation. So whether we have X or Y doesn't really matter a whole bunch, but let's swap it anyway so that we kind of get this. So let's go into select data. And so our X values currently are T, our Y values are U. I want to just swap those. So I want that to be U and U, and I want this to be T and T. Okay, there we go. So we can still see this clustering, and we can still see there's a correlation. One other way we can go about doing this is actually with the Corel function, which gives you a value and either a positive, between +1 and -1, whether the correlation is positive and strong, so which would be, closer to a 1, or is it negative and strong, which would be closer to a -1, or is there really no correlation at all, where we would see a value around 0. So I'm going to take this for now. This is kind of interesting. I'm going to Command X. I'm going to cut that chart, and I'm going to paste that in here on our exploration summary tab and say, this is something that's interesting, is our transaction count and amounts. So again, without spending the time, we could format this. But now I want to go one step further. So kind of like we did for ages, where we split it by gender, what I want to do here is say, well, I wonder if there's any kind of correlation here between, again, like I suspect, so I'm hypothesizing that someone who's going to cancel their card is probably more likely to have fewer transactions and for smaller amounts than someone who's going to remain with the card, right? So again, the null hypothesis there is that there's no effect, but I'm going to hypothesize that there is some kind of connection between how often someone uses their card and how large or what the total amount of purchases on the card is. That's going to relate somehow to whether or not they churn. So what we need to do is have some way of coloring these points by whether the customers are traded or not. And so we can do the same kind of thing that we did for gender in our Explore data. So I'm going to leave count as the unchanged. This will be our X values, but I want to get the transaction amounts here in terms of whether the customer is attrited or not. It doesn't really matter which we choose because we're going to color them anyways, but this is the way I'm going to do it. So let's insert, and this will be the last thing that we'll do here, and then I think this has gone on long enough. So let's update this. So we'll have attrited total trans AMT, and we'll have exists total trans AMT. And so we're going to do the same thing here that we did for female. We're just going to split this. So I want this to be equal to if going way over to my attrition flag. If the attrition flag equals a traded customer, then I want the value to be what's in my total transaction amount. And otherwise, we'll use the NA function again. Fantastic. So first customer is not attrited. I'll use the fill handle to put that down. And so that's where I would expect to see my first attrited customer. And that is, in fact, where I see it. So that's good. So this is good. And then I want to do the same thing for my existing. And so this is, we're going to plot these same points on the same chart. And then that way we can give different colors and we can color them. It's a bit trickier to do it here than in some other programs, but it still works. So I'm going to copy this. Now I'm looking for existing. So I'm going to change attrited customer to existing customer. And good. So I would expect, where I don't see a value here, I should see one there. I should be able to pop that down. And there we go. So where I do see one here, I don't there, etc. So I'm going to do the same thing. And here I will. I'm going to copy and we'll try this. Paste special values. There we go. Okay, and so now I want to use these U and V with a W on my X. So we can go ahead and make that change here. So let's go back to our chart. We can go to table, chart design, select the data. And so I've got this current series, but I want a different series. So this series is going to be attrited total transaction amount. So that's U. And so W is fine for my X, but I want the Y values to be U. So we can do that. And then I want to add another one. So series 2, this is going to be my existing total transaction amount. So that's going to be V. The X values are going to be W. And my Y values are going to be my existing total transaction amount. So I think that should do that. So I should be able to say OK. And there we go. Now, I kind of have one behind the other, and we can clearly see there's some difference. We can modify the series so that we bring that one to the front. So go select data. Let's move this one down and say OK. And then we'll add a legend because that's going to make it much easier to read this thing. So our existing customers are the orange dots, and our attrited customers are the blue dots. And so here we can clearly see that these two variables, these two features, the total transaction amount and the total transaction counts, those are good indicators. They're not like the only ones, but those are good indicators as to whether or not a customer that we're looking at might cancel their card in the near future. We can clearly see there's a split right around here. So in terms of transactions amounts, so just around kind of like the 10,000 mark, Anything above, I expect I'm going to keep those customers. So anything below around a 10,000, that's a customer I might be concerned with. And also in terms of the number of transactions they're making. So anything beyond kind of like this, 80 mark, I'm probably going to keep that customer. But anything below, so any customer that's making fewer than like 80 transactions in that 12-month period, that's someone who might churn. That might be someone that I want to reach out to. So we were able to use correlation here, but also with coloring to find a feature or a couple features that might be really useful in performing our classification. So when it comes to choosing features, those are two that I'm definitely gonna keep in mind. So that's kind of it. We've done a lot. If you stuck with me this long, thanks. It did take a little bit of time. There are a couple of other things that I was thinking I could get to, but I think at this point are maybe just overkill. So hopefully this gives you some idea of how you could use Excel to perform some data exploration. There are a number of different functions you can use. Maybe real quickly, just to finish these examples off, I'll show you how to use the correlation function. So we could have also identified, now not with the coloring, mind you, that the idea that using transaction amounts and counts would be useful for classifying. But whether or not these two variables were highly correlated, we could have done that with the correlation function. So the correl function takes in a couple of ranges. So in this case, two arrays, sorry. So here, the two arrays are going to be, we have the total transaction amount, and we had also the total transaction counts. And so here we can see what the correlation value is. And like I was saying before, it's either going to be anywhere between +1 and -1. And so we have a 0.8. And that's kind of very high. So this tells us that these two variables are highly correlated. Again, that doesn't say anything as to whether or not they're going to tell us anything about whether a customer is going to cancel or not, but it tells us that we would expect to see that, as one increases, probably so does the other one. So there might be some kind of connection that's of interest there. So in addition to, being able to visualize things with like scatter plots, you can also use functions to do those things too. So that's it. We've come a long way. Again, hopefully you found this somewhat useful, and you could, again, have some fun with it. There's a lot of other things to explore. One of the things I didn't show was, for example, how to use the frequency function to build bins, but you can find tutorials online. Maybe I'll do a separate video on that. But that's kind of it. In the next video, it'll be a bit shorter, I think, because the process will go a bit quicker. I'm going to show you how to prepare your data for data analysis and data mining. Some algorithms prefer to work with number data versus the text or character categorical data fields that we have right now. So I'll show you how to do that transformation and preparation in Excel. And then we'll move on in later parts to exploring data in the Orange software, and then also finally running through some data mining algorithms in a later video. So look for that in the series. Until then, I'll say bye for now.